So let's say you're given a regular pentagon where all the sides are equal, and you draw a circle inside. So here, this circle is the end circle. It's my approximation, right? Ignore the gaps right here. But the circle would meet the midpoint of each side. And that midpoint, if we drew that to the center of the circle, we get something called an apothem, right? This line, which is the line from the midpoint of a side to the center of the end circle, is called the apothem. And I think I'm saying that correctly. I hope I am, at least. And our focus is, how do you find that length? And furthermore, if you're given that length, what can you find about the perimeter? But we're going to focus more on if you're given the side length or the perimeter of the polygon, how do you find the apothem? And here, right, let's say the perimeter of this pentagon is 40. So the perimeter, P, is equal to 40. Since there are 5 sides and they're all equal in this regular pentagon, we can find the side S. So P is 40. S is going to be 40 divided by 5, which is 8. So each side length is 8, and the apothem meets at the midpoint. So if this is 8 on this side, right, each segment here is going to be 4 and 4. Now, to find the length of the apothem, I would want to use triangles, because if I draw a line right here, right, you can kind of see that this should be a right triangle, and we can reason that it is a right triangle because this must be a right angle, because the side of the pentagon really is a tangent line to the circle, and if a tangent line meets a circle at a point, it forms a right angle to the radius. So we do have a right triangle. So the angle that we can use, right, is this angle right here. This angle, in fact, if you think about what's going on, if I just, let's say, draw this apothem as well, right? All the apothems around are the same. I know that the distance from this green apothem to this original one is 1/5 of the total circle, right? It's this angle right here is 1/5 of the full circle. And if you're not convinced, you can draw all the apothems to see that, oh yeah, if I draw all of them, how many are there? 1, 2, 3, 4, 5. Right? They meet the midpoints of each side. So they're each 1/5 of the circle. So this green angle, just like the other angles around, is 1/5 of 360, right? But the apothem is actually half of that, right? So it's 1/2 of 1/5 of 360, if that made any sense. We'll call this angle theta. So the green angle is 1/5 of 360, so 1/5 of 360. And then the apothem is going to be half of that. Right? You can see that it's half the distance there. So it's 1/10 of 360, or 36 degrees. So if we know that theta equals 36 degrees, right, we can use the tangent function to find the apothem. So the tan of 36 degrees is going to be equal to opposite 4 over adjacent, we'll call it A. And here, if you have your graphing calculator, right, we can find this. Oops. Let me adjust this. Okay. All right. So I'm going to be showing my modes in degrees. Okay, we're in degrees. And here, right, so if I want to find A, what would I do? Well, if I go back to some basic algebra here, multiply both sides by A, and we get A times the tangent of 36 degrees equals 4, and then to solve for A is going to be equal to 4 divided by the tangent of 36, right? So here, what is that? That's where our calculator comes into play. 4 divided by the tangent of 36 degrees, right? Okay, so we get about 5.5055. It depends how much you want to round. So 5.5055, right? And would have rounded there. So 2 is the next digit, so I can leave it here. So I'm rounding to about this, and that's about our apothem length in this, right, in this image here. Now, in general, the formula looks kind of scary, right? You get this thing, but notice it's exactly what we had here. You can kind of see S is side length, right? But notice this 2 down here. That's side length divided by 2. So our side length was 8 divided by 2 is 4. That's what we got right here. And we get the tangent of 36. That's just because you're taking the tangent, if you think about it, it's not the full 360 divided by the number of sides. It's half of that because we're dealing with these like triangles that are not the full distance between apothems divided by n, the number of side lengths. It's a general formula for what we did. Although I don't think you really need that. I think it's logical, right? But again, it's 180 divided by n because these angles right here, it would be 360 divided by n, but that would give you this full angle, the green one. We want half of that, so it's 180 divided by n. Anyway, so the way you can deal with apothems or whatever you're given is to use sine, cosine, or tangent. So just draw that triangle. Remember your SOHCAHTOA or whatever way you remember the basic trig ratios, and you can always find what you need. Thanks.